Hello everyone and welcome to a new Genesis Mega Drive tutorial video. In the previous two lessons we've studied how to put a sprite onto the screen and also how to animate it, and in this video we're going to learn how to create your own sprites. I also previously did a video on how to create Mega Drive graphics which focused more on creating backgrounds, and a lot of what you learned there is applicable here, so if you haven't watched it I recommend you do so and I'll put a link to it, but for now let's start creating some sprites. We're going to be using a sprite again as we did last time, and if you just choose RGB and transparent for now, and we're going to do it as 64 by 64 pixels. And on the left hand side we have the Mega Drive palette. If you haven't got that, then you can download it from the how to create Mega Drive graphics video. It's in the video description there. And again, just as a reminder, we have a palette of 512 colors and you can stretch it however you want. I want to minimize it here so we got plenty of space to see the sprite we're drawing. When you choose the transparent as the background, it'll create these squares, this grid, and they're actually 16 by 16 by default, but we can change that if we go into this option here. We can select and we can change it from 16 to 16 to whatever we like. I think I like to do 8 by 8 tiles because just like background, sprites are tile based, so I think it's useful to have the background as 8 pixel by 8 pixels tiles. The 8 by 8 tiles or the 64 by 64 pixel picture you're seeing right now is going to be a single frame of our animation. If we go down to the bottom here, you can see we have a single layer and you can rename that whatever you like, but we're only going to keep one layer here. We're going to keep it very simple, and what we want to do is add more frames of animation because we're going to need more than one, and you can use the add button here, or alternatively you can just simply press Alt N and it will create, it's a keyboard shortcut which I'm using now, and it'll create, every time you click it'll create another frame of animation for you. Just as with the lesson on how to create your own backgrounds, I want to keep things very simple artistically, just so we can focus on the technical details of how actually to do it, and do it so that it's compatible with the Mega Drive hardware. So what I'm going to do, I'm just going to simply draw a ball going across the screen, so it's going to be incredibly simple. Of course, if you want to know more on how to create sprites, you can simply do a search on YouTube, and there's lots of great tutorials to show you how to do it. So for now, I'll put this ball in the 10th frame by mistake, but we're going to start from the first frame. And then as you can see, if we click to the second frame, the ball isn't there because it's a different frame of animation. But if I've just simply copied and pasted this little ball I did at the beginning, so I don't have to keep redrawing it. So from going to 1 to 2, you can see how it's moving across the screen now. Now having to flip between them isn't very convenient, and instead we can use this onion function similar to what old animators use with their tracing paper. Now we can activate that by selecting this option on the screen, and you'll see that there's a less colourful version of the one before, and you can drag it across multiple frames, so you can see the animation on the previous frame and on the next frame too, and you can do this for multiple frames. This obviously makes it a lot easier when, especially if you're doing a complicated kind of walking or attacking animation, even just for a simple ball like this, it makes it much easier because you can see what the previous frame was doing and the frame before that if you want, and even future frames. It's definitely much more convenient than using paper as well, so we're very lucky to live in an era where we can use computers to do this instead. I'm just going frame to frame, pasting the ball I copied earlier, and obviously you'll spend a lot more time if you're going to do like a proper walking animation or any other kind of a fire animation or anything else, but to keep things simple, as I said, we're just going to have this ball here. If I go and select the first frame of our animation and then push the play button here, the animation will now play, and we've still got the onion skin enabled so you can see all the animations at the same time. But if I disable that and push play again, then we will just see the ball itself without the before, previous and after frames of animation as well. For this simple example, I simply have one color, green, and plus of course the background would also count as a color. So as far as the Mega Drive concerns, this will take up 2 colors of the palette, and the sprites, they can only be 16 colors. So we've already used 2 here. So make sure you keep track of the colors and don't go over 16, including this background, the checkered background as well. So you have to keep an eye on that. I gave some tips in the how to create graphics video back a few weeks ago, so you can check that out. While using a simple ball was a quick and easy way to show you the process, let's pretend for a second that I am actually a talented pixel artist and use a much more attractive sprite. Okay, so with Axel here we have a much bigger sprite. It's 15 by 16 tiles large, and we have 17 different frames of animation from a stationary, an idle, a walking, and of course the grand upper. And just like with the ball, if I go back to the first frame and click the play button, then the animations will play one after the other. But the problem is they're all playing together, and of course these are separate animations. So rather than having to create separate files, we can do something, we can implement a little feature called tags. This allows us to group different frames of animation together and give them a label. So for example, the first one we're going to call it stationary, then we're going to select all the frames of the idle animation, and if we do new tag again, then we can simply call this idle. And of course we can do the same with the walking and also the grand upper animation as well. One of the advantages about this, as well as making it look a bit neater, is now when we press the play button, it's not going to play every single frame in the file we have here. It's just going to play whichever tag is currently selected. So we can play just the walking, just the grand upper, just the idle animation, and so on. We can change the speed of the animation by right clicking on any one frame and selecting frame properties, and then within that you can change the duration in terms of milliseconds. So at the moment it's defaulted here to 100, but we can change that. So just as an example, let's go to the final frame of the grand upper animation and we can change that number to make it 500 instead of 100. So it's quite normal for any attack to have the final frame of that animation to linger a bit longer than the rest of the frames to give it a bit more impact. I can't remember if that's how it's done in Streets of Rage 2, but I'm just doing it here as a demonstration. As well as just doing one frame at a time, of course we can select multiple frames and at the same time and alter their properties together, so you don't have to do it one by one. So again, I just choose the grand upper just for demonstration purposes. Let's change this to 200 and let's see how it looks. It looks a bit strange now, but I hope you now understand how to change the frame speed. Now I should emphasize that the speed you choose here has no effect on what happens in SGDK. The information isn't carried over. You'll probably remember from that sprite tutorial where we put the speed of the sprites when we uploaded the sprite to the ROM. Now you also might remember a Castlevania episode I did a few weeks back where I explained how I did the bloody zombie animation. So it was 60 milliseconds here in a sprite, and I had to convert that from, because obviously 60 is the old Babylonian system, and then when we use milliseconds it's using the metric system, which is in terms of numbers of 1000, and so you have to do this calculation here to convert from the A sprite speed to the SGDK speed, the Mega Drive speed of 60th of a second, and you usually end up with some awkward decimal point that you either have to round up or round down. So let's pretend that you created this beautiful Axel sprite and now you wanted to get it saved so it could be compatible with the Mega Drive. Now the first thing to do is to use this new palette, create new palette from Sprites, so we can get rid of all the other colors, and thankfully if you've done everything correctly you should be left with 16 colors or less. The next thing you need to do to make it Mega Drive ready is to change the color mode to indexed. Before we go ahead and save this, first we need to create a sprite sheet, because at the moment it's just these individual frames of animation. So select export sprite sheet from the file option menu, and that will open up this little dialog box. Now make sure the sheet type is by rows, and next go to click on the sprite button. And what you want to do here is make sure that you tick the split tags option. What that did was it put each animation on its own separate line, which, if you recall the displaying sprites lesson, is exactly what we need for the Mega Drive to read it. And just make sure All the options are as you see here, and the final thing we need to do is to click open sprite sheet, and then finally we can export. Now that we finally have a sprite sheet, we can simply go to file and we can save as, and as with the background we need to save this as a PNG file. Now that we've discussed in detail about how to create sprites in a sprite in a way that the Mega Drive and SGDK can understand, let's talk a little about hardware limitations in terms of sprites. To do that, I'm going to use this early build of the boss fight I did for my Castlevania game, because it's going to put a lot of sprites on the screen, so we should get to see some flicker a bit later on. So the maximum, the size of the sprites for the Mega Drive are either 8x8 pixels, 16x16 or 32x32. Now in terms of Alucard or the two bosses here, they're obviously larger than that. So what it is, each character is made up of multiple sprites, and thankfully SGDK handles that automatically for us, so we don't have to keep putting individual sprites on the screen. If we use any kind of character that's more than 32x32 sprites, and it'll just put all the sprites together for us, so we don't have to worry too much about that. We don't have to micromanage it. Using the most common resolution here, 320x224 pixels, the maximum number of sprites can be on the screen are 80, and the maximum that can be on any horizontal scroll line is 20. So at the very top here you can see these fireballs are being generated all the time by I think it's called Gaiben here. So as he does the next one, we should start to see some sprite flicker, and actually we're seeing it already, because not only is the flying boss and all the fireball sprites, but also the HUD is actually a sprite. So the fireball on the left there, you can see is starting to glitch out, it's starting to display some flicker, as is one of the fireballs on the right. So the Mega Drive is actually pretty good in terms of displaying sprites, unless you go overboard as I'm going here. The sprite flicker was a big issue for 8-bit systems such as the Master System and NES, but for the 16-bit systems it was a problem that tended not to come up very often. And just in case you don't trust the emulator very well, here is the same demo on real hardware. So you can see the sprite flicker is pretty much the same as we had in the emulator. Speaking of sprite sizes, previously you can see two versions of my Alucard sprite sheet here. This is the first one, an earlier one, and you'll later see the second one as well. Now in this earlier one you can see that Alucard's kind of shifted to the left, and that's because I was trying to fit his animations into the smallest animation cell possible, because I thought the smaller the better in terms of saving memory as well as trying to minimize any sprite flicker. But you can see that the reason I had to do it further to the right is because of this sword slash, and then his cape flows a bit to the left. So this is the smallest I could make it while fitting all the animation frames into it. However, that did make the code a bit more complicated, because obviously the sprite turns left and right. So if I do a horizontal flip here, as what happens in the code when Alucard turns left or right, his position changes because he's not in the center, he's to the left and now he's to the right. So that means that any collision code needs to change depending on whether he's facing left or whether he's facing right. So that creates a potential for bugs, as well as needing more code to be written. So I didn't really like the aspect of it, but I thought it's something that couldn't be avoided. But next I did a sprite sheet where he is dead center, and obviously that uses more space either side. But the good thing is I was reliably informed that actually all this empty space, it doesn't count as part of the sprites, the sprite size in the Mega Drive. SGDK apparently is very good at optimizing this, so any kind of blank space it will just ignore. It doesn't count as the size of the sprites, otherwise this sprite will be huge and we'll be getting lots of sprite flicker, and maybe it'll take up a lot of VRAM as well. So for these sprites, even if I flip them left and right, he kind of stays in the center, so I don't really need that kind of extra code Of course, in terms of the attacking animation, he attacks to the left or the right, and that the code needs to change a bit in that circumstance because the position of the sword changes. But in terms of the level collision and enemies hitting Alucard, I can pretty much keep the same code just because he's in the center now, and fortunately I don't actually have to worry as I thought I had to about all this empty space wasting free RAM or just contributing to any sprite flicker because it's not counted in the size of the sprite. So SGDK is really great in that way. So hopefully it doesn't take up too much space in the ROM, in the VRAM, and we can still avoid the sprite flicker as well. There are also some parts of the animations that don't really change much from frame to frame. So for example, in some cases Alucard's head would stay in the same position, and it might seem wasteful in that circumstance to have all these have the face pasted over and over again, but again I'm informed that SGDK actually optimizes that, so hopefully it doesn't take up too much space. It's possible in the future if you want to have it fit in as smaller ROM space as possible, you might need to optimize a bit yourself manually, but it seems okay so far. Although the Mega Drive and the Super Nintendo are generally very good at displaying bigger sprites than the 8-bit consoles were, there are limits of course, and for this kind of boss where it takes up half the screen, I would recommend using an old trick from the 8-bit days, and that is to use a background layer. So thankfully we have two, so we have one to spare. So in terms of massive bosses, massive sprites like this, I would just recommend using the background layer rather than using an actual sprite. Of course, one of the main advantages of using sprites is the ability to move them and control them. So in the next lesson, I'll be start to teach how to program the controls for Mega Drive games. Okay, so I think that just about wraps things up for this video. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.